Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Aidan Finn, MVP Cloud Mechanix Ireland, who will be talking to you today about getting more performance from Azure virtual machines. Remember to join the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC19. Don't forget to check out the Resource Center. This is packed with the latest blogs, ebooks, webinars, and how-to videos. Simply visit SharePointEurope.com and click the content link at the top. Grab yourself a great deal. Check out our super early bird offer for ESPC 19. Get up to €350 off your ticket. See SharePointEurope.com for full details, along with the big announcement this week of our keynote speakers, including Jeff Tieper and Scott Hanselman. After the webinar, we will have a questions and answers session. Type any questions you have for Aidan in the questions window. Questions will be selected and answered at the end of the presentation. This webinar is being recorded and you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Aidan Finn. Hello, Aidan.
Hey Shane, how are you?
I'm great. Take it away.
Cool. Greetings everybody from the Midlands of Ireland, where it is currently kind of sunny and not raining, though that will change in the next couple of hours. My name is Aidan Finn, and I'm going to talk to you today about how to squeeze out a little bit more performance, or hopefully a lot more performance, from your Azure virtual machines. I'm a Microsoft MVP, as Shane said. I'm a Microsoft Azure MVP, to be precise. That's one of the expertises one can have. In the past, I have been a Hyper-V and a System Center Configuration Manager MVP. I work with Azure on a daily basis. It's what I do all day long, and I focus on virtual machines, networking, security, and stuff like that. And I do that for a company called InnoFactor. To be precise, I work with the Norwegian branch of InnoFactor as a principal consultant in the cloud platform infrastructure team. I also run my own company called Cloud Mechanix, where I have written my own custom hands-on Azure infrastructure training, and I've brought it around Europe. You can find more about that on cloudmechanix.com. Also blog on aidanfinn.com, and I tweet as @Joe_Elway, and you'll find articles that I've written as well on petri.com about Azure over the last few years. So before we talk about performance of virtual machines and how to squeeze out more, we really need to understand what it is we're working with. So we have to look at the architecture of virtual machines. Now, for some people, they might think, well, that's too basic for me. But the reality is, and I find this in the complex stuff too, sometimes you have to go back into the basics and relearn them. The stuff you're taking for granted that maybe, you thought about it 2-3 years ago, maybe even 10 years ago, but it's not something that you really consider anymore. And it's that sort of thing that you have to go back and refresh on. So what is a virtual machine made up of? Well, it's made up of a bunch of things, and those things will help us figure out how we design these Azure VMs, how we size them, how we start troubleshooting, now not just performance, but everything, and how do we enhance the performance of these virtual machines. So a virtual machine, it's consuming a number of things from the physical host. Obviously, that's going to have an impact. So it's consuming disk, it's consuming networking, it's taking CPU from the host, and the host specification, which we'll have a look at later on, does impact the VM performance. But there's a couple of things about the virtual machine we have to think about as well. So there's the configuration, or the metadata of the virtual machine. And this describes the virtual machine. It tells you the label of the virtual machine, the human-friendly name for it. It will tell you the number of virtual processors, the number of disks, the locations of those disks, and how they're connected, and all that good stuff. That's actually of very little value. That's stuff that we can, when we delete an Azure VM, that's deleted. The stuff that gets left behind when you delete a virtual machine is the high value stuff. This is where your operating system, your applications, your settings, and your data reside, and that's your disks. And they play a big role in the performance of your virtual machine. Here's a simplified diagram, and it's very Windows focused, to be honest, but it's, apart from one line, it applies to Linux as well. This has simplified architecture of how a VM is built up in Azure. So on a Hyper-V host, which is part of what we call a compute cluster, we have the virtual machine where it is running. So the metadata is loaded here, and the virtual machine consumes CPU and RAM from the host, and it connects to the network. Now that networking is used obviously for communicating on a virtual network, so the application is available to clients or other services. But it's also used to connect to storage. And normally, and there is one exception to this, which we will look at later, normally the virtual machine's OS drive is stored on something called a storage cluster. Now you can think of this as being a SAN, but there are exactly 0 SANs in Azure. All of our disks are stored on this software-defined massive environment. Typically, you're talking about something that might be 1,000 physical machines with lots and lots of disks inside them, and the blocks of your disk are spread across that compute cluster. Think of it as being something that makes a SAN look small. So your disk is stored across the network. So there's a certain element of latency with that. A Windows machine, if you're deploying it for the marketplace, it's normally 128 gig disk, though you can specify a small disk option, which is 30 gigs if you have a short-lived virtual machine. Linux tends to be smaller, though you can customize these sizes, and of course you can upload your own virtual machines as well to have different disk sizes. That OS drive has read-write caching enabled. Now we're going to come back and look at that later, this caching, but we're not to modify that read-write caching on the OS drive. By the way, the cost of that OS disk is not included in the cost of your VM. So when you're looking at the price of a VM, the OS disk is an additional cost. The second drive you'll see in your virtual machine is something called a Temp Drive. You'll often see Microsoft call it the ephemeral drive. Temp Drive says everything you need to know about this thing. If you reboot that virtual machine, you gotta count on getting a different temp drive. This is not for where you store data that you want to keep. If you put data you need to keep on that temp drive and your virtual machine gets rebooted, prepare your CV or resume, because you're going to need it in a whole new type of career. Data should not be kept on that temp drive unless you're willing to lose it. What kind of data are we willing to lose? The paging file. So the paging file is placed on the temp drive, and we'll look at how things like SQL Server can take advantage of that temp drive to improve their performance later. That temp drive lives in the Hyper-V host. It is not across the network in the storage cluster. Reason being is it's closer to the processor, and it means storage latency is lower. That's great for the paging file. And on all but one of the types of virtual machines, which is the oldest type of virtual machine, that temp drive lives on SSD. On the oldest form of virtual machine we have on Azure, that actually lives on HDD. So for most of the machines we would deploy, the temp drive is close to the processor and it's on flash storage, which means our paging file can be really, really fast. Now, where do we store our data? Well, we don't put it on the temp drive. By the way, we don't put it on the OS drive either. We'll talk more about that in a while. Your data always should go on data disks. I don't care what the virtual machine is, how much data you're talking about. Domain controller, for example, sysfile, database file, log files, all should go on your data disks. And there can be one or more of these data disks, and that's dictated by how many disks you want versus how many your virtual machine's spec can actually support. And we can configure read caching or read-write caching on those disks if we wish as well. So we have virtual machines up and running. We want to figure out how they're performing or why they're performing bad. Well, you need monitoring. And simple rule, if you don't measure it, you can't manage it. So if you have not configured monitoring, you are not managing your virtual machines. It's a hard rule, but that's the way it is. So use the tools that Azure gives you. Some of them are actually, we'll call it free. There is an actual cost, but it's such a small cost that I never even bother estimating it. You're talking about a few pennies or a few cents per month. The tool we're going to use is Azure Monitor. So Azure Monitor allows us to aggregate our data into a central place. And there's a few ways Azure Monitor does this. For virtual machines, you'll typically go into the settings of the virtual machine. You'll go to diagnostic settings, and you will enable the virtual machine to send data to somewhere. A cheap way of doing it is to a storage account. If you wish, you can send that data to a workspace or log analytics, or even what it used to be called on the marketing banner or licensing banner of OMS. Now we have lots and lots of data, not just about the physical performance of the virtual machine, but also, from importantly, inside the virtual machine where the application lives, because it's the application that dictates the performance. It's the application that we care about. It's not the actual Linux or Windows OS. It's the application. It's the database. So we need to get that data out of the guest OS. So Azure Monitor allows us to visualize these things, compare them, look at the history of how our virtual machine performed versus how it's scaled. We can also do alerting. So you can start managing by exception. Instead of sitting there looking at a chart every day, set up notifications using alert groups, and then create alerts for your individual machines. If you want to delve a little deeper, that workspace thing, that log analytics thing, that's now called Azure Monitor Logs. Everyone loves a rename, and that team love to rename their product. Azure Monitor Logs gives us a feature called Virtual Machine Insights. Now we get lots and lots of data and health information about our virtual machine as well. And that can all be brought back into this Azure Monitor. We can create alerts on it and look at reports and all that good stuff. Now, an important exam question is, well, you want some advice on how to resize your virtual machine. Where should you go? The exam answer is Azure Advisor. The real world is don't go near it because it's useless. That's my real world experience. Azure Advisor doesn't really give you good advice. It doesn't understand things like availability zones versus availability sets and stuff like that. And it never seems to recommend B-series virtual machines. And I'll explain why that's important a little later on in the slides. If you've worked in virtualization on premises, so if you've worked in VMware, Hyper-V, Zen Server, that sort of thing, you probably realize that the most important thing for your virtual machine project being successful was the storage, typically a SAN. And the same is true here in Azure, or in any cloud, to be quite honest. The performance of your virtual hard disks will be the primary thing that drives the performance of your virtual machine. It's typically not CPU. It's usually disk. And that's been my experience in some extreme stuff. So the disks, what are they? Well, they are Hyper-V VHD files. They're not VHDX, and they're fixed size. Once upon a time, Microsoft used to tell us, in fact, the guy who's the chief architect of Azure today, a guy called Marko Savinic, he used to stand on stages and tell us to use dynamic sized VHDs in Hyper-V because there was no performance deprecation. I knew back then that was not true, and I used to say that, and Microsoft didn't like me saying that, and it's true in Azure. So they use fixed size VHDs. So when you deploy a 32 terabyte virtual hard disk, you are actually getting 32 terabytes of physical capacity. 32 terabyte. What's a terabyte? A TIB. Remember once upon a time when a terabyte was 1024 gigabytes? And then along came the likes of Apple who said, that's too confusing for our customers. We're going to get a terabyte rebranded and resized. So a terabyte is 1,000 gigabytes, and a gigabyte is 1,000 megabytes. Have a look at your iPhone. Now, how many megabytes of storage have you really got on that iPhone? And that's true of most marketing stuff now. So Microsoft used the scientific term of a tebibyte. A tebibyte is 1,024 gigabytes, which is 1,024 megabytes, etc. So it's the true scientific stuff. We can deploy virtual hard disks of up to 32 tebibytes in size, and if that's not enough, we can aggregate them together. However, the largest size that things like Azure Backup currently support is 4 tebibytes. The 32 terabyte size was just made generally available in the last couple of months. So if you do want to protect your virtual machines, you'll stick with a max of 4 terabytes. However, I would expect Azure Backup to increase that in the relatively near future. I'll say this again, and I will say it again later on. Don't put data in that OS drive. Always use the data disks. Your disks, when you deploy them, will be stored in at least triplicate resiliency. And if you deploy the disks the way I tell you to, they will have triplicate redundancy. And if you want to go into other regions, you can. So when our disk is stored in that storage cluster, it's not stored once. Each of the blocks that made up the disk are spread across the entire cluster, and they're stored 3 times. So that's better than RAID 10. That's 50% better than RAID 10. So we can lose 2 copies of our disk effectively, and we still have an operational virtual machine. And of course, you should never be deploying 1 virtual machine. You should be deploying 2 or 3. That depends on the particular application that's running in there. You might not be able to, but we have those opportunities. We have that architectural possibility. There are 2 ways we can deploy disks. The old and the new. Well, the old and the 3 years old. The old is what's called on an unmanaged disk. And then the new is a managed disk. Unmanaged disk, don't do it. It's quite simple. Use managed disks. If you have an old Azure deployment, you probably have unmanaged disks and you haven't upgraded them. It basically requires you shut down the VM, run a PowerShell command, and the VM will start up automatically. Managed disks are easier to use, offer you more features, and they're the only thing Microsoft have actually developed in the last 3-4 years. Unmanaged disks go into something called a storage account, which is kind of like a LUN and a SAN. You have to uniquely name that thing, and you have to create lots of them if you want to get good performance from your VMs. So use managed disks. Why are unmanaged disks a bad choice? Well, they're stored in a thing called a storage account, as I said earlier. That storage account has a max performance of 20,000 IOPS. So if I put 5 P30 premium disks, now P30 is a size of a premium SSD drive. It's 4 terabytes in size and gives us 7,500 IOPS, not the 25,000 IOPS that's listed there. 5 of those things are going to require roughly 37,500 IOPS. Or they're going to offer me up to 37,500 IOPS. However, my storage account, if I put all the disks in there, can only give me 20,000. So I'm not getting what I'm paying for. Whoops. So what you're supposed to do is track, right, how many IOPS am I asking from my storage account? How many IOPS can my storage account give me? And spread my disks around. Sounds crazy. It is. It's why you shouldn't do this. Use managed disks. Azure manages the placement, and you get way more management features. Cool thing about managed disks is those managed features are all GUI. So we can do nice, simple things and complex things in the GUI. And we can do more of them than we can do with unmanaged disks. Unmanaged disks, if I want to do a simple task, I need a long PowerShell script that I got to Google from somewhere and hope it still works. Use managed disks. If you've got unmanaged disks, upgrade them. Shut down the VM, run the PowerShell command, the VM will boot up for you. There are 4 tiers of disk available in managed disks, the one we should use. Unmanaged is actually only 2. So unmanaged only gives us standard HDD and premium SSD. Managed disks, the one you should be using, gives us all 4. So we have standard HDD. Microsoft like to tell us this is for test and dev only. They say that because it's the cheapest and they want you to spend more money. The reality is a lot of workloads will work fine with standard HDD. Low-end databases, domain controllers, small to medium file servers, all will work perfectly fine with standard HDD. Typically, those disks give you up to 500 IOPS and are capped there. Now, some of the very large ones, which Azure Backup doesn't support yet, will give you up to 2,000 IOPS. Typically, 60 megs per second on the throughput. However, some of the large ones will give you up to 500 megs. They are the entry-level disks. Up a slight level from there is standard SSD, and this one's relatively new. This one came out in the latter half of last year. Standard SSD, it's the same performance tier as standard HDD, however, there's some subtle differences. It's supposed to have lower latency, however, in my stress testing, I did not find that. But what it does give you, because it's flash-based, is a smoother level performance. HDD spinning disks have an up and down level of performance because you have multiple different operations, effectively multiple virtual machines or even multiple customers, hitting that single spindle. So that disk has to do a seek and read for every single operation, and it can only do those one at a time. So flash storage can do lots of seeks and reads in parallel because it's flash. It's got a bus going into it. So that's where you get the smoother level performance with standard SSD. Premium SSD takes things up another level. So this is flash storage. It's the oldest version of flash storage that we have in Azure. And this gives us performance of up to 20,000 IOPS per disk. It gives us very low latency. Now remember, it's still network-based storage, so the latency is under 10 milliseconds is what I found in stress testing. And throughput of up to 750 megs per second. One of the nice things about premium SSD is if we have some virtual machine or some application that we can't deploy as a load balance cluster or a failover cluster or an application layer cluster, and we can't avail of availability sets or availability zones to get qualified at VM for an SLA. So it's a single VM, like a legacy application that only runs on one VM or a single file server that's not going to be clustered. If you want to get an SLA on that virtual machine, you must deploy it with all premium SSD disks. And then you get your SLA for that virtual machine of 99.5%. However, the actual runtime will probably exceed that SLA, to be quite honest. The newest type of disk, or the newest tier of disks that we're going to be getting, and it's in preview at the moment, is Ultra SSD. And this gives us up to 160,000 IOPS and 2,000 megs per second on a single data disk. This will also come with the VMSLA option. This is, really fast storage, and Microsoft are referring to it as Flash Direct. And premium storage. This actually applies to somewhat to the Ultra SSD. Certainly the first piece does. The virtual machine that you deploy, and we'll be looking at virtual machine sizes and series in a little while, must be an S variant virtual machine. So the name of the virtual machine must have an S for you to attach premium SSD storage to it or Ultra SSD storage to it. Your premium storage, the performance is actually based on the size of the disk. So the bigger the disk, the bigger the performance. And why is that? Well, it's because of that parallelism of flash storage. The bigger the file, the more opportunity is for the actual physical disk to do lots of reads at the same time and lots of writes at the same time. So you get better IOPS and better throughput. Now, one of the things you've got to be aware of with premium storage is you can't just assume that if you give a VM or an application premium storage, that you're going to get better IOPS. It really depends on how your application reads and writes. So if you've got a single-threaded application, so something that was written 20 years ago, and you chuck premium storage at it, you're probably not going to get any boost in performance at all, really, in terms of IOPS. Your latency will certainly come down. But the IOPS and the throughput really won't increase. Where you will see that is things that are multi-threaded, things like modern Oracle or modern SQL Server applications that really can hammer a disk because they are multi-threaded. Well, that's when premium storage really comes to life. And you'll see that if you use a tool like Iometer. It's easy to get Iometer to stress out a standard HDD disk with just a few threads. You take that same test and run it against a premium disk, and you won't see any performance improvements. You'll actually have to start running 64 workers with lots of threads per worker. And that's when you see lots and lots of threads going on, hammering that disk, and you will reach those ridiculous numbers of IOPS that are possible with premium storage. Your performance of your disks is also going to be bound by the size of the virtual machine. So a single virtual machine is going to have a maximum level of throughput and IOPS, and that's based on the size of the virtual machine. Now, this isn't Microsoft trying to squeeze more money out of you. This is a simple thing. If that virtual machine is taking 10% of the host, Microsoft are giving you 10% of the host's performance capacity. So they'll give you a certain amount of network performance and a certain amount of disk performance. So obviously, the bigger the VM, the more host capacity you'll be entitled to. So your single virtual machine has max throughput, max IOPS. Okay? It's possible to give a virtual machine more disk performance than it can actually consume. So I could put lots of these premium SSD disks onto a low-spec virtual machine, and then my performance will be constrained by the spec of the virtual machine, not the disks. So this is like taking an old PC and putting a really fast disk into it. The really fast disk might give me lots of performance, but is the motherboard really capable of driving that performance? Same deal as this. There's a few things to consider when you're driving disk performance. So this is just a summary. We'll go through the slides now to actually go through it in detail. Disk caching. So I talked about the OS drive on your host having read-write caching. You do not modify that. Data disks, we can modify the read caching and write caching. So there's three different options. We've no caching, we've read cache, and read-write cache. What's going on here is we're consuming some free resources from the host. There's no actual cost to enabling this caching. We're being given memory or storage capacity on the host to enhance the performance of our data disks. Now, it's typical to see read caching because things like SQL Server and Oracle love read caching. However, be really, really careful with read-write caching. Think of it like this. You've got an application or a virtual machine, and it writes some data to a data disk. If that goes into a write cache, where is that write cache? It's on the host. And as far as the application is concerned, it's committed that data to disk, but it's actually sitting in the write cache. Now, if that host has a failure and the virtual machine fails over to another host, where's the write cache? It's on the old host and it's lost. The virtual machine is now powered up on another host, and as far as it's concerned, it's already committed that write. So the write is lost. So you can end up with corrupted databases. So earlier on, I warned you with domain controllers. Put your sys file, your database file, and your database log file on a data disk. Don't put it on the OS drive. Why? Because the OS drive has read-write caching enabled. So if Active Directory commits a write to disk, and it goes into that write cache on the OS drive, well, it's not necessarily gone into the OS drive, really. It's still on the host. So you could end up with a USN rollback if that domain controller gets moved to a different host. And everybody loves USN rollbacks. Oh no, they don't. They don't like working all weekend with Microsoft Premium support. So watch out for that. So typical things, SQL Server, Oracle, read cache, we normally like that. We'll talk about an exception on that in a little while. So when we get extreme. Read-write caching, only do it if your application explicitly requires it. Don't take a guess. Disk caching, I love it. It does improve read performance like crazy, and it's free. Everyone likes free. And that pretty much summarizes that slide, or what I was saying. What if you need more performance than a single disk can offer, or even more capacity than a single disk can offer? We can aggregate disks together. So I could take 4 of those P30 disks that I mentioned earlier, those premium SSD 4 terabyte drives. Each give me 7,500 IOPS, and they each give me 4 terabytes of capacity. I can aggregate them together. Now, how do I aggregate them together? Well, I get a virtual machine that can support 4 data disks. I deploy 4 data disks to the virtual machine, then I log into it. So in the case of Windows, I'll log in and I'll use a feature called storage spaces. Now, if you're not familiar with storage spaces, and I mean really familiar, you'll think, Aidan's telling me to do Windows RAID. He's a muppet. No, it is not Windows RAID. If you use Windows RAID back in Windows 2000, yeah, it sucked. It was really, really bad. It had awful performance. Storage spaces is more along the lines of what a SAN actually does. And by the way, SAN isn't hardware RAID, it's software. So storage spaces is very similar to that. It aggregates disks together, and then it takes capacity from those disks to create LUNs or virtual disks. So the pooling of disks, or the aggregation of disks, is referred to as storage spaces as a pool. And from that, we can create a disk. And we'll use the entire capacity from that pool to create a single virtual disk or LUN. Format it, and we end up with 15.98 terabytes. So we only lose 0.02 of a terabyte of capacity. And how many IOPS do we end up with? 30,000. If we enable read caching, we get more on our reads. So we get a lot of performance by aggregating disks. And it's a cool technique, and it's something you'll see in the SQL Server performance guide for Azure. Another thing, if you want to maximize your performance of your disk, is format your disk correctly. And this is driven by your application. So if your application does reads and writes of a certain block size, you should try to align your NTFS or your REFS volume size, or whatever it is on the Linux side, with that. So on NTFS, for example, when you do a format, typically you'll go next through the wizard. And there's a bit in there about allocation unit size that most people, and I'd probably say 99.99% of people, never even look at, never have looked at. And that should be formatted to match the read-write size of what's going on in the virtual machine. So typical size that you'll see being used by people who are trying to optimize things, particularly for things like SQL Server or on-premise, if you're formatting a CSV volume for Hyper-V, set it to 64 kilobytes. And that will give you typically your best aligned block size for things like SQL Server. What about dedicated data disks? If I have a small SQL server, I might put the log files and the database files on the same disk. And that's fine, because it's a small SQL server. I might not ever hit the maximum performance level of those disks. But you get to the point where you might say, I want to dedicate IOPS to a certain kind of read-write action on here that's random, and for my database files, and I might have serial writes going on for my log files, and I want to allocate a pool of capacity for that. So I keep those 2 different pools of capacity isolated from each other. So when we're doing extreme level things with SQL Server or Oracle or whatever, you might have 2 different pools of disks for your data. 1 pool of disks for your databases, 1 pool of disks for your logs. And Microsoft wrote in the SQL Server Performance Guide for our Azure VMs an interesting note. When they stress tested the log file disks, and those log file disks had read caching enabled, they actually had a minor drop in performance. And that's because there are no reads really going on with the log files. Well, there shouldn't be. It should be write. And the only time we typically read from a log file is when something bad has happened with the database. So the database files will be stored on disks that have read caching enabled, and the log files will be on a different pool of disks that don't have any caching enabled. And that's if you want extreme levels of performance. What about host local storage? Well, I told you don't use the temp drive. It's where the paging file lives. We can afford to lose the paging file because it effectively gets flushed when we reboot the virtual machine, and some people actually deliberately do that in their security configurations. Now, when we're using anything but the oldest types of virtual machines, this temp drive is flash-based. It's being used for the page file. But if you've looked at the size of the page file versus the size of the disk, you'll realize there's actually a lot of free capacity left on that temp drive. Why did Azure do that? Is there another reason? Yeah, it's because there's certain types of disk-based cache that we can afford to lose that can take advantage of that temp drive's closeness to the processor, closeness to the RAM, and its flash capacity. So SQL Server, in their performance guide, they recommend moving tempdb to the virtual machine's temp drive. And if you're running something called NoSQL, well, you might actually use a special type of virtual machine that only uses local drives on the host. We'll talk a little bit more about those later. If you're lucky enough to be working with something called the M series virtual machine, and if you are, you're working in a company that has a very big IT budget, then you've got something called Write Accelerator available to you. And this will boost your write performance on your disks. And ideally, you'll do this on disks that do things like redo logs, transaction logs, that sort of thing. You won't do it for database file disks. It's very easy to set up with a new disk when you're deploying it, or a new virtual machine when you're deploying it, but it's a bit complicated to do it when the virtual machine already exists. So that's storage. Let's talk about networking. We're working in the cloud here, so the network is kind of important to connect to our applications and to connect applications together. If you've looked at virtual data center concept, it's all about networking. So our virtual machines have a limit on how much bandwidth they can do, or how much network throughput they can do. And this is per virtual machine, not per NIC. By the way, NIC teaming is not possible with Azure VMs. It would make no sense anyway. The idea is if you want more throughput, you go with a larger VM size. So you get a larger share of the host's capacity because you're entitled to it, because you're using more of the CPU. What I'm going to talk about, well, if you started working with Hyper-V before 2012 or around the 2012 timeframe, you may have heard of something called single root IO virtualization, or SRIOV. And vSphere has a similar type feature as well. Typically, when packets are going in and out of a virtual machine, they flow through something called a virtual switch, which runs in the parent partition of the host and runs in user mode. So basically, there's an S-shaped loop that goes through the Hyper-V architecture where there's a number of context switches. A packet comes in from the physical NIC on the host, goes through a context switch onto the virtual switch, then goes back out to the VM bus, goes through another context switch, goes across to the VM bus to the child partition where the virtual machine is running, another context switch, and then goes into the NIC. And then the guest OS is able to process that packet. And there's a lot of context switching going on, and there's a bit of latency involved in that as well. If we enable something called single root IO virtualization, or as Azure calls it, accelerated networking, that's a much friendlier name, that virtual switch loop is bypassed. Now packets go straight from a physical function on the physical host's NIC to something called a virtual function, which is the virtual machine's NIC. So there's a much shorter passage of packets between the host and the virtual machine. You get less jitter. So for media type things, for phone type systems, this is going to be good. Lower latency, which is always good. And there's lower CPU impact. Accelerated networking was recommended by Microsoft when they enabled the fixes for Spectre Meltdown last year on very large virtual machines. They said if you wanted to claw back your performance, you would do this because there'd be fewer context switches, which is where the fix for Spectre Meltdown actually impacted the performance. On very, very large VMs, so your 32 processors and up and all that sort of crazy stuff, you'll get a minor bandwidth boost by enabling accelerated networking. It's available for a subset of guest OSs, so Windows, all of the Windows servers, and the major Linux distros, and it's on some of the VM series. So basically, look for machines with 2 physical cores, not virtual cores, but physical cores. And it can only be enabled when you create the NIC and when the VM is actually in a deallocated or a powered off state. And if you're using classic virtual machines, get off those things. We're well past Vanilla Ice and Ace of Base and that stuff now. Join us in the year 2019 and use ARM VMs. That's when you can start taking advantage of this particular feature. What if you can't use that feature? What if you can't use accelerated networking? Well, if you're deploying a virtual machine from the marketplace, it should have this particular this Hyper-V feature called Virtual Receive-Side Scaling enabled. Inside the guest OS, it'll just be called Receive-Side Scaling, and you'll see it in the properties of the NIC inside the guest OS. If you've uploaded your own virtual machine or migrated your own virtual machine to Azure, you should probably go into the guest OS and check that this feature is enabled. So this can be done in Windows, and it should be already enabled in Linux, but just check it as well. What does receive-side scaling do? It's basically, without receive-side scaling, when a packet arrives on the NIC, an interrupt is sent to core 0, and only core 0. So if there's a lot of packets coming in on the NIC, the packets will only be processed by core 0. So you may have an 8-core virtual machine, but only core 0 is able to process those packets, and it becomes the bottleneck on network processing. So the potential bandwidth of the virtual machine gets reduced to whatever core 0 is able to handle. When you enable receive-side scaling, those interrupts get sent to more cores. Therefore, you're able to reach a higher level of potential and potentially the virtual machine's limit on bandwidth. Right, that's storage and networking. Now let's start talking about processor and other things that the virtual machine and the host can offer you, and how that drives your performance, the availability of features as well. This stuff causes a lot of people to panic. The last time I heard someone in Microsoft talking about numbers of particular virtual machine options out there, I think they said it was 175 different sizes of virtual machine in Azure. That's probably over 200 at this point. People look at this, they get blinded by all the options and they panic, and then they go, well, can't do cloud. I just don't know how to do it. I am hopefully going to make this easy for you by explaining how the naming system and the sizing system works. And it's actually pretty simple. And there's a couple of little memory tricks to remember what all the different letters and numbers mean. So we've virtual machine series. All of the virtual machines fall into a particular series or family of virtual machines in Azure. And this is nothing new. Although they don't use the term, HP have series of physical servers. Dell have physical series of servers. Lenovo have physical series of servers. If you think about HP, DL320, DL360, DL380, DL560, etc. The Dell side, you have R430, or 630, or 730. If I said to you, I need you to spec up a rack-mounted VMware or Hyper-V host, I bet you automatically you're thinking of either a DL380 or an R730 or whatever. There's a particular 2U server you have already in your head. If I said to you, you know what, I actually just need a tower machine, it's going to be a domain controller and file server and a small branch office, I bet you there's another spec of virtual machine already in your head. And in Azure, you're hopefully going to get to that point. All of the virtual machines are broken into these different series, and within the series, we find the size that gives us the performance, the processor, the memory that we require. These series are also broken into generations. So HPE, which the physical servers I'm most familiar with. Yeah, G5, G6, G7, Gen 8, there's an interesting story there, G9, etc. And in Azure, an example would be D, DV2, which was the successor to D, and DV3, which is the successor to DV2. So that makes things a little easier. Within a virtual machine name, there are specializations, special letters that tell us something unique about that virtual machine, some special feature or thing that it supports. So I've already mentioned the first one, S. If the virtual machine's name has an S in it, it means that that supports premium SSD. And when it comes out, Ultra SSD. But it also supports the other lower tier disks, so standard HDD and standard SSD. If the virtual machine doesn't have an S, it only does standard HDD and standard SSD. So S. It used to be short for SSD, but now standard SSD kind of muddies up the water. M. More memory than usual. That's simple. So basically, if you see that, it's, well, fairly similar to a machine without the M, except it's got more memory. OR stands for RDMA, Remote Direct Memory Access. That's a form of NIC. And the brand and the type that Microsoft use here is Mechanix InfiniBand. So if you see a virtual machine that has an OR in it, it's typically designed for something called high performance compute or high performance clustering. And that's a virtual machine that has a second NIC that is one of these Mechanix InfiniBand NICs, and it's on a very special fiber network. It basically does memory-to-memory copies over a network. Very low latency, very low throughput. It bypasses the networking stack in the guest OS to get really, really fast and very low latency. And then we have I. These are the big guys, isolated. This is the only virtual machine on that host. So it has all the performance potential that that host can offer. And you won't be deploying too many of those unless you work for a very special organization. So let's put this all together. I have a D-series virtual machine. I'm going to talk about what that means in a little bit. And it's a D4S V3. Well, I know it's a D-series and it's a V3, so it's the third generation of D-series. Because that virtual machine was released in the last 3 or so years, that 4 actually means something. It means it's got 4 virtual processors. And because I know the D-series and how the maths work, I actually know it's got 16 gig of RAM. Well, my 8 virtual processors had 32 gig of RAM, was 2 processors, that's 8 gig of RAM. And it's got an S in there, so it supports premium SSD. By the way, if that was a D4S V2, the 4 would actually mean it was the 4th one that Microsoft wrote down, and it's actually got 8 cores. So it's really only the virtual machines in the last few years where the 4 means 4 virtual processors. And all this is documented by Microsoft as well. If you go into your favorite search engine and do a search for Azure VM sizes, you will find all of this documented and every one of the sizes. So, S and non-S variants. If I see a DV3 and a DSV3, which one do I go with? Well, the answer is I go with DSV3. Why? Well, they're actually the same cost. The only difference is the disk price, potentially. But the DSV3 supports the same disks as the DV3, plus it also supports premium SSD and will support Ultra SSD. So why would I go DV3? Well, customer once asked me that. Why would I ever go DV3? It makes no sense. If I go with DV3 and I find in my performance monitoring I need to go to a premium SSD disk, I actually need to shut down and resize my VM to do that. So if I had just gone with DSV3, which was the same price to run anyway, I could just convert my disk. So I don't have any VM disruption at all. And Microsoft kind of realized what we were up to. When we stopped deploying the DV3 instead of a DSV3, they actually started having shortages of the DSV3s. So in the last couple of series of virtual machines that they've launched, they've only been S variants. So you have BS series virtual machines and FSV2 virtual machines. I can deploy these with premium SSD if I want, or I can deploy them with standard HD or standard SSD or a mixture. And you'll see clever people actually doing that mixture. Maybe the OS drive is standard HDD, the data drive is premium SSD. So let's get into these letters and series of virtual machines. AV2, A is the start of the alphabet, and it was the first of the virtual machines in Azure. It is the oldest. And it was actually based on back in the day, a physical Opteron processor that was known more for electrical efficiency or cost efficiency instead of performance. So these days, Microsoft simulate that processor, so they still degrade the performance somewhat to simulate or mimic what was offered back in the day. It doesn't have any S variants. It only does standard tier disks. It was the cheapest of virtual machines around. It isn't anymore. And it's rare now that I would actually ever deploy one of these A series virtual machines. Most recent one is the AV2. Over in the D series, D is for disk, D is for database. And we have the DV3 and the DSV3. Which one do you deploy? You deploy the DSV3 because it makes no sense to deploy the DV3. This is where we start using or seeing Xeon processor performance, plus the temp drive is SSD. The A series, the only one where the temp drive is HDD. Now we start seeing much better performance with these D series virtual machines. Great for SQL Server workloads, great for Citrix workloads. And you know what? Turned out they're great for typically any application workload. It's only when you start getting to extreme levels of performance that you need to go higher. We have the BS series. But typically people just call it the B series because BS kind of means something else. B is for burstable. And this is actually the most common virtual machine I typically see in a mature environment now. So the BS series is actually based on the same hardware as the D series, but it has something special about it. Most applications don't need 100% of their processor performance. In fact, they typically are using less than 12% of their virtual processor performance potential. Why would you pay for that all the time? It makes no sense. So the BS series, what Microsoft do is they give you a virtual machine that can burst to the same CPU performance as the equivalent D series, which is higher spec than the AV2 series, by the way. And they cap it artificially. And while your virtual machine stays below that cap, that threshold, your virtual machine saves up credits, puts CPU money in the bank. So when your application does need to exceed that threshold, it burns that CPU money in the bank. So it can go to 100% of the performance potential of the D series. So what you'll find with the B series is a lot of people who might have deployed the A series in the past are actually shutting down the VM and converting it to B series. And some people who are underutilizing the processor of the D series are doing the same, shutting it down and converting it to B series. We've got compute optimized virtual machines, the FSV2, which is a cousin of the DSV3. It's a newer processor though. Where the D series, what you typically see is something like 2 cores, 8 gigs of RAM, 4 cores, 16 gigs of RAM. The F series, it's more balanced. 2 cores, 4 gig of RAM, 4 cores, 8 gigs of RAM. It's not that often I actually see that though, because typically people are not using processor all that much. It's really the memory and the disk they're really depending on. Commonly I get asked, do Microsoft have NVIDIA support in Azure? And the answer is, boy, do they. They have 3 different groupings of virtual machines with constant improvements on these, particularly in the NC series. We have the NV series. N is for NVIDIA, V is for virtualization. So your Citrix, your RDS type workloads where you want to use a GPU for things like AutoCAD and all that stuff, you can do that. NC, C is for compute. This is where you want to do compute-intensive work like simulations. ND, D is for deep learning, artificial intelligence, Chrome robots that are going to step on our spines. This is, for that type of workload where you want to create neural maps and do that computational work in a GPU. If you need more memory, lots more memory, well, the D series has a bigger cousin. It's basically the DV3, but with more RAM, and it's called the EV3. That's for bigger database workloads. Now, if you want to go extreme, the old extreme in Azure was the G series. G is for Goliath. And that's what they actually said in their marketing. G is for Goliath. These were, just like the guy, these were the biggest boys around. Now they're not, because we've got the M series. M is for massive. And these are the biggest virtual machines in the cloud. And these have driven Hyper-V zone maximums. So the largest M series virtual machine right now is about 3.8 terabytes of RAM. 3.8 terabytes of RAM. And yes, they are increasing that to about 11.8 terabytes of RAM. I can't wait until the day I have an application that requires that. I hinted at this earlier. The LSV2 series virtual machine. This is a very special virtual machine. It does not store its disks on that back-end storage cluster. Its disks are actually on the host, and the disks are NVMe flash, which means they're really, really fast. This is taking advantage of a feature in Hyper-V 2016 called DDA, or Discrete Device Access. So the virtual machine is using physical access to these drives through the hypervisor. So it's getting native levels of performance. So you get up to 80,000 IOPS and 1400 megs per second throughput on each data disk on this virtual machine. Blah, crazy. And then we have the H series. H is for high performance compute. And these are the ones where you'll find the OR designations or specializations. Typically deployed in large clusters of machines to do some huge task that'll be processed across lots of virtual machines. You'll typically use RDMA networking to then share that data across those virtual machines. In the real world, what do I see? Number one, B series. People who know what they want or figure it out afterwards. How? Using Azure Monitor. They're monitoring the performance of their virtual machines and looking at the CPU utilization. And they're saying, well, I don't need to pay for a D series, or I don't need to pay for a more expensive A series. In fact, if you go from A series to B series, your maximum performance processor or processor performance goes up, and your cost comes down by about 70–75%, going from A series to B series. And it's great for that burstable workload. If you need constant high CPU utilization, you go with D or A series. Number two, D series. People are looking for disk performance, database level performance, and any of the A series. Typically, this is legacy type workloads. If I don't really know what I need, but I know it's going to be on the lower end, I go A or D. Very low end A, and then I go D. And then I recommend using that Azure Monitor tooling and monitor the CPU after about a month. Just run a report and have a look and see, right, is the CPU actually staying low? If it is, range the maintenance window, shut down the VM, change the size, power up the VM, and you're saving lots of money without any deprecation of normal performance. And if you've gone from A to B, you've actually increased performance. That's a win-win situation. Take those money savings, go to your boss and say, hey, I just saved the company this amount of money over a year. I think that should go into my bonus. Thanks very much. So some CPU notes. Something you've got to watch out for, and especially with the newer VMs. When you see something like, oh, it's got 4 virtual processors, those are 4 virtual processors typically if it's on an Intel host, not 4 cores. So the D4v3 has 4 virtual processors. That's 4 hyperthreads living on 2 cores. A D2 or D4v3, or sorry, D3v3, which has 4 virtual processors, is actually 4 cores because it didn't have hyperthreading enabled on the host. So the newer machines, if they're Intel, typically have hyperthreading enabled. So when Microsoft went from D2v or DV2 to DV3, the overall CPU performance went down by 28% because they enabled hyperthreading. However, for most database workloads, that's not an issue. They're not about maximum gigahertz. They're about having more threads. Anytime I've monitored the performance of database, it's not been about gigahertz, it's about give me more threads. I have more tasks that want to run in parallel. And that's when you're also able to drive your premium SSD performance. So yeah, they reduced the overall performance, but they also reduced the price. So for database workloads, we probably got the same level of core or threads, or even more threads, and the cost came down by 28%. That's pretty cool. Typically, another interesting thing, if you do see that hyperthreading is enabled, that virtual machine, if it's running Windows, probably can run nested Hyper-V, which is kind of cool to run if you need a temporary Hyper-V lab environment. What about encrypting your disks? Because you can do that. It's cool. You can store your BitLocker keys in that in Key Vault. So you basically have a virtual TPM that resides off the VM. BitLocker in your Windows really won't have that much of an impact on your disk performance. Now, there's one exception to that. CPU, it'll cost you about 3% of your CPU, which is typically not your bottleneck of performance anyway. There's a guy I know called Daniel Newman who did some interesting tests. He works for Microsoft. He tested all kinds of variations on disk encryption and disk sizes and disk tiers and stuff like that. And he found there was one interesting one, which was the P10, the premium SSD data disk. When he enabled BitLocker, he actually had a loss of 30% of write IOPS. But nowhere else did he see that. It was just one weird thing. And that was a few years since he did that or did those tests, so that may have actually changed. Typically, there's no loss of performance by enabling disk encryption in the guest OS. So a couple of tips to wrap up. Do your monitoring and make sure you're doing it at the OS and application layer, because that's where the root cause actually is. That's where the symptom is showing. Go and look at that stuff. Understand that application. Is it single-threaded? Is it multi-threaded? How does it like to do writes and reads? What block sizes does it like to use? Make sure you're enabling those diagnostic settings in the VM. If you haven't got it done, go back and do it. It's easy to do, and it costs you next to nothing. You're looking at pennies per month for the table storage in a storage account, or even a very low per gig charge in a workspace in Azure Monitor Logs or Log Analytics or OMS if you want to call it that. Use the tools. Azure Monitor has lots of data there. Use it. The exam answer is use Azure Advisor, though I'm being polite by saying don't rely on that 100%. Use Azure Monitor. The data is really useful. If you have the ability and you have Log Analytics deployed or Azure Monitor Logs deployed, use Azure VM Insights. There's a lot of data in there as well. And experiment. If you're going to be doing something big, deploy proof of concepts. Deploy out multiple versions of it. Do different variations of configuration of disk and CPU and RAM and stress test. You think about it this way. If you watch motor car racing like Formula One or something like that, they spend months every year just testing. It's because there are lots of different configurations, and they'll tweak those cars for every single racetrack, and they could spend 3-4 months doing that over the winter, and then even before going out to on the race, they will tune the car for maybe half a week. Do the same. Okay, I'm not telling you to do it for months, but spend time on those high-end workloads to figure out the best configuration of memory, disk, CPU, etc. for that particular application. So that's the end of my presentation. I hope you have gotten something from it. This was a presentation I gave at European SharePoint Office 365 and Azure Conference in Copenhagen in 2018. It was a pretty great conference, and they're going to be running again later this year I'm sure Shane will be able to remind me, it's in December in the Czech Republic.
Correct, in Prague.
So check out the early bird pricing. It is a great conference and a huge wealth of presenters from around the world, including Microsoft, and MVPs from around the world as well. So check it out, and thank you for tuning in.
Thanks for a great presentation. Yes, now we will start the questions and answers part, and should you wish to ask Aidan a question, type it into the question window now. Aidan, we have some questions in. First one is, are there any downsides to using BS series virtual machines?
For the most part, no. There's one interesting gotcha with the BS series virtual machines, which I found actually during a training course way back, which is they don't support disk caching on the data disks. And that's the only gotcha I actually found with the BS series virtual machines or the B series virtual machines.
Okay, cool. Next question we have, when would I need to enable RSS in a virtual machine?
Well, it's normally enabled in any images you deploy from the Azure Marketplace. Where you will need it probably is when you do a migration from on-premises. So if you're using Azure Site Recovery or whatever to migrate virtual machines from Hyper-V or VMware or even physical up into Azure, you probably don't have receive-side scaling, especially in VMware. You probably don't have it enabled in the guest OS. So once you've got your virtual machine up there and you've cleaned it up and stuff, go and enable receive-side scaling, and that should improve your networking performance of your virtual machine and even out the flow of interrupts across your the physical cores that the virtual machine is using.
Okay. Here's a question. Today, someone made a joke on Twitter asking, "What's your preferred database?" The answer was one maintained by anyone else. Same joke applies here. What's your favorite virtual machine?
uh, the one managed by Microsoft and not me. Using platform or as a service, PaaS. I'll give you an example, actually. I've been doing a lot of work over the last few months for Innofactor on networking, so large network deployments for pretty big companies. And the topic of virtual firewalls came up.
Great.
And yeah, I have not found a virtual firewall that I like as an appliance. That's not an Azure thing, it's just in general. I think they all suck. That's my personal opinion, not that of the event or the webinar. Because there's so much painful VM stuff that has to be done with them. Whereas I can go into Azure and use the Azure firewall and it's all platform. Plus all the clever security stuff is distributed. So I'm able to take advantage of machine learning and the Microsoft Security Graph to dynamically block stuff that comes from bad addresses, even though it's targeting open ports. That's dynamically blocked. I don't need to create any rules or anything. That's just done. And I don't have to patch anything. I don't have to upgrade anything. I don't have to worry about load balancers or any of that stuff. I literally just say, I want a firewall. Here's my rules. And Microsoft improve it for me. They give me new features, new functionality on a pretty fast basis. And other clever things distributed around my network, like everyone asks for, well, I want IDS and my Cisco this, that, and the other, and my checkpoint that and the other. And it's like, well, my IDS is spread around the entire network. It's called Security Center and NSG flow logs, not in a single point of failure and a single vendor of failure. So my favorite VM is the one I don't manage. But if I was to pick a VM that I had to deploy, I really, really do like the BS series because it reflects typical application usage of processor, which is bursty and it's cheap, especially if you have the ability to throw in things like hybrid use benefit for Windows licensing, cost reductions, and reserved instance for compute cost reductions.
Sure. Great. Aidan, our time is up on this side as well, so we're going to have to wrap it up there. On behalf of the ESPC community, thank you, Aidan, for taking the time today to complete this webinar. We really appreciate it.
No problem. Glad to be on, Shane.
Great stuff, Aidan. Thank you so much. Okay, everybody, that is it. That is the end of today's webinar. Please see sharepointeurope.com for details on all upcoming webinars or visit the Resource Center for all previous episodes. Thank you all for joining us today. Take care and goodbye.